And we've returned. This is going to be a couple more examples finding both the point slope form and the slope-intercept form for a linear equation. So say for instance, we want to find the point slope form given a line with slope +3. That would be the same thing as like a 3/1. If we wanted to think of it as a fraction, we want the line to go through the point -1, 3. So we can essentially just jump straight to our point slope form. Whoops, let's do one line at a time. So that's right, sort of y minus y1 equals the m slope value times the quantity x minus x1, right? So my x1 and y1 would be -1 and 3 respectively, so y minus 3. I've got x minus -1. That's really going to be an x plus 1, right, if I sort of start to rewrite it. And then the 3 in front of my parentheses is just my slope. We said you can think of the slope always as a fraction. If it's not given as a fraction, you could always write it as 3/1. That'll be useful when you're graphing, but just as far as finding the equation, just leave it as a 3. That's totally fine. There's no reason at that stage to turn it into a fraction just to work with it, right? We'll just leave it as is. And that's the form, right? That was incredibly fast. Just sort of subbing these numbers in, just doing a quick right, minus minus becomes plus. We go from there. To rewrite it in slope-intercept form, all we're doing is we're trying to solve it for the y value, right? So I'll just do a quick little distribution on the right. 3 times x, 3 times 1. So that would be 3x plus 3. So you can sort of see, don't mind the little coffee stains. Y minus 3 equals 3x plus 3. Right, if I do this distribution. And then from there, I'm just adding 3 to both sides, right? Add the 3 over. And I essentially get this y equals 3x plus 6. So 3 is still my slope, and that must mean that +6, y equals 6, would be my y-intercept in that form. If I run another example, one thing I could change is instead of just sort of giving the slope and a coordinate straight off, I could just give you an equation of a line that goes through 2 different points. So the extra step here is we need to actually sort of solve for the slope as a step number 1. We're not given the slope, so we actually need to solve for it. So this is just a throwback to what we were doing 2 videos ago, right? The first 2.3 video. We just need to do a manual slope calculation and go from there. So in this case, x1, y1, right, would be -4 and 5 respectively. X2, y2 will do as -6 and 2. So I'll just set up my slope formula. We can see it here, right? So y2 minus y1 over x2 minus x1. That's going to be our slope calculation. That's our sort of rise over run, as we were sort of saying in the other video. The change in the y values divided by the change in the x values. As long as I'm being consistent with which one I'm calling sort of 0.1 and 0.2, I'm pretty much good to go. In this case, if I sub my numbers in right, so y2 is 2, y1 is 5, so 2 minus 5 up top is -3. The bottom looks like -6 minus a -4. That's really -6 plus 4 would be sort of -2. -3 over -2, well, negative over negative is really going to be a positive 3/2, right? +3/2. Once I have the slope, I'm just doing the same kind of steps we've been doing the past couple problems, right? So I'm just sort of throwing all this information into my point slope setup. And the idea here is I can use either the -4, 5, or I could use the -6, 2. Either one of those points I can use in my point slope equation. I used, in this case, it looks like I used the second point, -6 and 2. You could just as easily have used -4 and 5. Either one of those is totally legitimate, and they're just 2 different versions of the same equation. What will happen is by the time you sort of solve it for the y value in your slope-intercept version, it'll actually all come out in the wash and you'll end up at the same place. In this case, I did -6 and 2. So my original version here, if I sub those things in, y minus 2 equals 3/2 times the quantity x minus -6. Minus -6, of course, would be x plus 6. So my version, my cleaned up version, y minus 2 equals 3/2 times x plus 6. So that's the point slope form, right? It's sort of boxed, so that's our sort of answer A. To rewrite it in slope-intercept form, all I need to do is distribute, right? So 3/2 times x and times 6. 3/2 times x. 3/2 times 6, you could think of this, right? 3 times 6 is 18, divided by 2 is 9, right? Or 6 divided by 2 is 3, 3 times 3 is 9. Either of them gets you there. So distributed on the right-hand side, this would be 3x plus 9. You can see then in red, so this would be y minus 2 equals 3/2 x plus 9. From there, I'm just adding 2 to both sides, plus 2 plus 2. And my final version, my slope-intercept version, y equals 3/2 x plus 11. I'll try to get this out of the shadows here. So that's the idea. That's how we're going to sort of get these two different versions of these equations. Simplifying all this stuff, just sort of setting it into the formulas and cleaning it up as needed and rearranging it. So that is point slope form and slope intercept form. Next thing we're going to do is use it to make some graphs.